So let's conclude our discussions of corporate debt and bonds with some pricing and a few statistical questions. This worksheet that you see here comes from the bond valuation and duration worksheet. The value of a bond is the sum of its remaining coupon payments plus the present value of the maturity at the end of the bond's life at whatever the current required return is for the bond. Bond prices and interest rates have inverse relationships. When interest rates rise, existing bonds with lower coupon rates become less attractive, causing their prices to drop. Conversely, when rates fall, bond prices rise. This is what happened during the COVID crisis, when central banks lowered rates that boosted bond prices globally. So understanding this relationship is crucial for bond investors. In this example, we have a bond as a $1,000 par value, 10% coupon, has a 10% required return, 10% 10-year time to maturity, and one compounding frequency per year. Typically, bonds pay interest semi-annually. It's a little easier to see the concepts when we just think about once a year. But to find the value, all you need to do is change the compounding frequency to a 1. So in this case, the value of this bond is $1,000. What would happen if expected inflation rose by 3%, causing the required return to increase by 13%? Substituting for required return, 13 for 10, we see that the bond value falls when the required return is above the coupon rate. That's bond value is going to fall below par. We say this is selling at a discount. Now, selling at a discount doesn't mean anything bad. It just tells us that the price relative to $1,000 is lower. So again, as rates change, bond values change, and they move in the opposite direction of risk. What about yield to maturity? Yield refers to different types of returns. The current yield is the return on this year from the coupon. Here, the yield to maturity, the current yield is 10.15%. That is its coupon divided by its price. It has a $90 coupon. It has an $887 price. That gives us 10.15%. The yield to maturity is the return if you buy today and you hold to maturity. In this case, if you paid $887 for this bond and you held it for 10 years, received all of these $90 cash flows and the $1,000 at the end, you would have earned, on average, 10.912%. So if you buy today and you hold to maturity, that's the rate of return you expect to earn on average per year of your investment. If bonds sell for par, then these are equal, right? If the bond sells at a discount, though, the yield to maturity is higher than the current yield. What does that mean? Think about the current yield, the coupon, as what the company wants to pay you. The yield to maturity is what you want to receive. So in this case, if the bond is selling at a discount, the company doesn't want to pay you as much as you want. You want the current yield, you want the yield to maturity. the company wants to pay the coupon. Since they're not paying you everything you want and desire, you may still want to buy the bond. You want the cash flow. However, you won't pay as much for it because they're not giving you everything you want. If the bond is selling at a premium, that means its price is greater than par value. What this means is that the current yield, what the company wants to pay you, is actually higher than what you want to receive. They're willing to give you something extra. You're willing to pay for that extra. So as time changes, two things change with a bond, generally: time and interest rates or risk. The coupon is the cash flow we receive. High coupon bonds may sell at a premium. The yield to maturity will be higher than the other yield to maturity since the coupon rate is higher. We mentioned something called callable debt earlier in a video. Earlier in a video, we talked about something called callable bonds. What happens if the company wants to call the debt? This only happens when interest rates have fallen substantially, but the company will pay you what's referred to as a yield premium. In this case, if they call the debt, they can call it in 5 years. They will pay you $1,050 for that bond. So think about what you received in these 5 years. Each year, you received $50. That's 5 payments of $50. That's the coupon each year. In addition, you're going to be paid $1,050 at the end of that 5th year. So essentially, all we're doing is substituting this yield premium for the maturity value at the earliest date that this bond can be called. In this instance, the yield to maturity is 7.98, and the yield to call is 7.51. Right? When would this company call? They would only call if interest rates, again, would fall far enough to reduce the total cost. As an investor, you want to think about the chance that interest rates fall far enough that the price rises above $1,050. So in this case, you see that what the price here is already $11.35. So this bond would have been called a long time ago. If you use the solver function in Excel, we can solve for how low rates need to go to get to that price of $1,050. Any rate lower than that would exceed the call premium and the call would be made. So in general, if a bond sells at a premium, then the coupon's greater than the required return, a call is likely. So if a bond is a premium bond, you would expect to earn the yield to call. On discount bonds and par valued bonds, you would expect a discount to earn the yield to maturity. Again, as we talk a little about interest rate and how that impacts returns, let's think about the credit ratings. In this case, we have two bonds, two categories of bonds: industrial bonds that are either AAA or Baa. Look at the differences in the returns. Obviously, you see the higher risk bonds, the Baa bonds, have higher yields. That makes sense. Here's our spread that we see here. But one of the things we may also want to associate here is to look at the volatility, right? So the spread between high credit and low credit shows that lower credit bonds are more sensitive. When interest rates change or when things change, they seem to change and be much more reactive than the higher yield bonds. Duration is a statistic. It's a weighted average length of time. I kind of think of this as kind of like being the payback period at capital budgeting. It can calculate how long the cash, etc., how long will it take for us to get that back from the initial price. More technically, it measures how sensitive bond prices are to interest rates. So it shows the average time which all payments are received. Longer durations means the bond is more sensitive to changes in interest rate. So this formula, again, is for duration. It's a fairly complicated formula. We'll talk about this here in a second. We can also calculate something called the modified duration. That's this D star. And D star here is you take that duration and you divide it by 1 minus the yield to maturity. Now what we can see here is we do have Excel formulas. The challenge in the Excel formulas is you must have the exact dates, the exact date of maturity, and the current settlement date, or the current date that we have. If you have those two dates, we can use this Excel formula to calculate this. In addition, we could do it with just duration, but again, we need the exact dates. In the bond valuation worksheet, duration is calculated for you if you don't have the exact dates for the debt. Sometimes our example will say there's 30 years left in the bond. We don't know the exact time frame. In this case, again, we can calculate out and find the duration of this bond. It's a 9%, 12% yield to maturity bond. Here's the dates. There's 3 years, and there's one payment per year. That gives us then a duration of 2.75. All by itself, that really doesn't mean much. It doesn't mean much. But compared to other things, the greater the duration, the greater the sensitivity to prices. So let's look at this example. Again, we see that the duration here is 9.39. This is the modified duration. If interest rates increase by 0.1%, bond prices are going to fall from 887 to 878. Duration measures the bond's sensitivity to interest rates changes. Longer duration bonds are more sensitive. Again, if you substitute different time maturities here, everything else staying the same, you will see the change in duration. So the overall topic of duration is a little bit beyond the context of this class, but it must be said that there are always ways to calculate interest rate risk. There is some discussion over whether you use duration or modified duration to measure the change in price. Most agree that you should use modified duration. As a sidebar, the curve that describes prices as interest rates change is not a straight line. So technically, as we'll find maybe in a later course, we want to measure something called convexity, which again complicates the issue slightly, but it adds to it the curvilinear nature of the actual curve itself. So duration can be used to estimate how small price changes, how small changes in interest rates make price changes in bonds. In this case, again, if this bond has an 8.62%, the duration was 9.39, what would happen if interest rates rose to 8.64%? You plug in your formula, That's negative 1.88%, which means we would expect the price to decline by approximately $17. Again, though, we know that the interest rates went up, so that means the price had to go down. So can we use this duration? And as I mentioned, the actual use of duration is a little bit more of a corporate finance context, but certainly anyone that is managing pension funds, large amounts of portfolios in the bond areas, they're all very interested in interest rates. Immunization means we want to match the time when funds are needed to the duration of the portfolio. Again, this is used more by institutional investors than individuals. If you needed money in 7 years, duration of your portfolio should be 7 years rather than maturity of the portfolio. What this means is this will help us equalize the reinvestment of the coupon payments, the risk of changing interest rates, with the change in prices over that time. So this will help us to eliminate both reinvestment risk and interest rate risk. So again, the idea of immunization is twofold. We want to prepare for changes in interest rates over time. This will ensure that when we're planning for future needs, we need to incorporate reinvestment of future cash flows with predicted changes in interest rates to have the correct amount of money needed with the minimum investment required. Again, just a graph to try to look at how duration shows itself graphically. Again, here we see the bond price. Here we notice that it's really a curvilinear function using that convexity idea. The brownish here shows a straight line. Now we know that line doesn't exist. This was the real line. And you can see for very low changes in the middle here, really the value doesn't change much. But for very extreme value changes in interest rates, the convexity nature can be very important to understand what happens to value. So how can we manage a bond portfolio? Well, we've talked about the difference between passive management, active management. Passive management, you buy and hold. What would you do with active management? So let's use an example. Let's assume that you need $100,000 in 20 years. How can you get $100,000 in 20 years? We have many choices now that we're thinking about bonds. We could buy 100 government bonds, zero coupon bonds, in fact, that all would mature in that 10 years. And when it matured, we would have $100,000 guaranteed because it's risk-free. The problem with that is the low rates of return. If we could get higher returns, we might be able to invest less of our money, that is, tie up less of our investable money, and still get the values we need. We need to be able to manage this cash flow pattern. There are several ways to do this. A straight ladder holds bonds of equal face value for equal intervals of time. So maybe we would hold we'd have 10,000 in 1 year bonds and 2,000, 3,000, 4,000, and we would rotate those through. When one set would mature, we move that out to the next time frame. So when the 1 year's matured, we get that money, we reinvest that for 10 more years. A barbell strategy would be where we're trying to offset the differences between short maturity and long maturity. Matching, try to match the cash flows with needs. The matching strategy is where immunization is going to be most important. And of course, we have all kinds of strategies with what are referred to as swaps, right? In this case, we could swap future cash flows for those of another investor's bond if we wanted to match our needs. So there are many of these active strategies that are possible. I will tell you, I'm not a bond investor. Right? My holdings in bonds are limited to mutual funds. So I am not worried about necessarily any of these active management strategies. My portfolio management team, they are the ones that utilize active management to ensure that I get the highest rates of returns for my bond investment portfolio. Thanks for watching the video. See you soon.